Swayam Prabha. Digital India. Educated India.
Yogah karmasu kaushalam.
Element of cost overhead part 3. Dear friends, I am Dr. Chetna Marvadi, Assistant Professor, School of Commerce, Gujarat University. Today we are going to study about element of cost overhead part 3. Dear friends, in the previous module we had acquired information about first method of overhead apportionment, where overheads of service departments are apportioned to production departments only. This is known as non-reciprocal method. Further, it has two sub-methods. Number 1, when two service departments are given, and number 2, when more than two service departments are given. Now, in this module of overhead, we will understand second method of overhead apportionment, that is reciprocal base method, and under the head of reciprocal base method, sub two methods of it are to be studied. These are number 1, simultaneous equation method, and number 2, repeated distribution method. Let's understand reciprocal distribution method. This method is followed when service departments are mutually dependent. For example, service department X renders services to service department Y, and service department Y renders service to X also. Thus, each service department receives services from each other service department. If there are three service departments X, Y and Z, then the same treatment will be given as it is given in the case of two service departments. The chart shows the allocation of service department overheads to production department and service department. Let's see both method of reciprocal distribution. Simultaneous equation method and repeated distribution method. In this method, the algebraic equation will be used for the apportionment of overheads. First equation is equal to x is equal to a plus b into y, and second equation is y is equal to a plus b into x. Now, let us understand with the help of illustration. Illustration 1. R Company Limited has three production departments A, B and C, and two service departments X and Y. The detailed information is given in the table. The primary distribution given for production department A is rupees 6,300, for department B is rupees 7,400, for department C is 2,800, and primary distribution for service department X given is rupees 4,500, and for Y it is rupees 2,000, thereby giving total overhead of rupees 23,000, which is given as primary distribution. The company decided to charge the service department cost on the basis, and their percentage are: for service department X, production department percentage given are for A 40%, for B 30%, for C 20%, and for service department Y it is 10%. And for service department Y, percentage given are: for production departments A 30%, for B 30%, for production department C it is 20%, and for service department X it is 20%. Find the total overheads of production departments by using two methods. Number 1, simultaneous equation method. Number 2, repeated distribution method. Let's prepare the solution. First, we will solve example using simultaneous equation method. Simultaneous equation method explained and given equation will be used. First equation is x is equal to a plus b into y, and second equation is equal to y is equal to a plus b into x. Here capital X stand for department X, small x stands for total overheads of X service department after apportionment of overheads of service department Y. Y capital stand for department Y. Small y stands for total overhead of Y service department after apportionment of overheads of service department X. A stand for primary distribution of overheads of respective service department. Let's solve the example. First step is formation of simultaneous equation. Let's assume X denotes total overhead of service department X, Y denotes total overheads of service department Y. Therefore, X is equal to 4500 plus 20% of Y, that is equation 1, and Y is equal to 2000 plus 10% of X, that is equation 2. So, X is equal to 4500 plus 0.20 Y and Y is equal to 2000 plus 0.10 X, that is our equation 2. Now, let us understand second step. Step 2 for solving simultaneous equation. Putting the value of Y in the equation 1. X is equal to rupees 4500 plus 0.20 into 2000 plus 0.10 X. Therefore, X is equal to 4500 plus 400 plus 0.02 X. Therefore, X minus 0.02 X is equal to 4900. Therefore, X is equal to 4900 divided by 0.98, which will give us X as rupees 5000. X is equal to total overhead of X service department after apportionment of overheads of service department Y, and that is rupees 5000. Now, let us understand step 3. Now, we have the value of X and we will put this value in the equation number 2, which is Y is equal to 2000 plus 0.10 X. Therefore, Y is equal to 2000 plus 0.10 into 5000, which is the new value of X which we have calculated in equation 1. Y is equal to 2000 plus 500. Therefore, finally, Y is equal to rupees 2500. Y is equal to total overhead of Y service department after apportionment of overheads of service department X, and that is rupees 2500. Now, let us understand repeated distribution method. First, we will understand steps involved in this method. First, apply the given percentage to distribute the primary total of first service department. In case of our question, it is X department, by charging the amount to other departments, production department A, B and C and service department Y. The actual amount of first service department, that is department X, is closed. Second, apply the given percentage to second service department. In our question, it is Y department, whose total is made up of its primary charges plus amount apportioned from service department X. This closes the account of second service department, that is Y department, but reopens the account of service department X. Third, repeat this process of distribution again with service department X, whose total now consists of only amount apportioned from service department Y. In this way, service department totals keep on reducing with each process of distribution, because each time a substantial amount is charged to production departments. This process is stopped at a point where it is felt that the remaining figures are too small to be of any consequences. Though this method produces only approximate result, but it can be conveniently applied where the number of service department is even more than 2. Let us understand secondary overhead distribution summary using repeated distribution method. Here we will prepare 4 columns. First column for distribution of overheads of service department, second column for production department, where we will have 3 sub column for production department A, production department B and production department C. Third column is of service department X and service department Y, and last column is of total. Total as per primary distribution given for production department A is rupees 6,300, for B 7,400, for C rupees 2,800, and for service department X primary distribution given is rupees 4,500 and for Y it is given rupees 2,000, making total overheads of rupees 23,000, which is given as per primary distribution. Now, let's allocate service department X overhead cost of rupees 4,500. So, we will distribute the overhead of X service department to production department A, B, C and service department Y in the percentage given. Amount comes for production department A as rupees 1,800, for B rupees 1,350, for department C rupees 900 and for service department Y it comes rupees 450. Now, let's distribute the overhead of Y service department, which is now rupees 2,450. Allocation comes to production department A as rupees 735, for department B 735, for production department C rupees 490 and for service department X rupees 490. This reopens the account of service department X. Now, let's allocate overhead of service department X to other departments. So, distribution of overhead of X department to production department A rupees 196, for B rupees 147, for C rupees 98 and for service department Y 49, closing the account of service department X. Now, it again reopens the account of service department Y by rupees 49. Let's distribute this 49 to other departments. So, now let's have a look at distribution of overheads of service department Y. The distribution is to production department A rupees 15, to B rupees 15, to C rupees 10 and to service department X it is rupees 9. Now, let's allocate this rupees 9 again. The distribution for production department A is rupees 4, for production department B it is 3, for C it is rupees T and for service department Y it is nil. Thereby, the total of service department X is nil and service department Y is nil. Now, it will give final allocation to production department A as rupees 9,050, to B it is 9,650, to C it is rupees 4,300, making total of rupees 23,000. Now, let's understand the above solution. In the above solution, first of all, the cost of service department X rupees 4,500 has been distributed to A, B, C and Y in the percentage given. Rupees 450 has been allotted to service department Y from the service department X. Now, the total cost of service department Y is rupees 2,450, that is rupees 2,000 plus rupees 450. This amount has been allotted to production department A, B and C and service department X. It means the account of service department X is again opened with rupees 490. As a part of the cost of service department, Y has been allotted to it. Now, this rupees 490 of service department X is again distributed to A, B, C and X in the percentage given. This process goes on till the figure of service department cost are reduced to very negligible amounts. Note that both simultaneous equation method and repeated distribution method produce approximately the same results. Now, rupees 5,000 total overheads of service department X will be apportioned amongst A, B and C in the proportion of 40%, 30% and 20%, which is equal to 90% because 10% are for Y department. In the same manner, rupees 2,500 total overheads of service department Y will be apportioned against A, B and C in the proportion of 30%, 30% and 20%, which is equal to 80% because 20% are for X department. Let's understand secondary overhead distribution summary. Here we have 4 columns: item, total, production department A, B and C. Total as per primary distribution which is given in the example is rupees 16,500, that is for A it is 6,300, for B it is 7,400, for C it is 2,800. For service department X it is 90% of 5,000 which is equal to 4,000, and the amount for production department A is 2,000, for B rupees 1,500, for C it is 1,000, and service department Y it is 80% of 2,500 which comes to rupees 2,000, and allocation for production department A is rupees 750, for B it is 750, and for C it is 500, making total overheads of rupees 23,000 which is distributed to production department A as rupees 9,050, for B it is rupees 9,650, and for C it is rupees 4,300. Total overheads of all departments are rupees 23,000, and after apportionment of overheads of service departments of X and Y to production department A, B and C, it would remain the same, that is rupees 23,000. A studied method of simultaneous equation gives accurate result, but if number of service departments is more than 2, the calculation becomes complication. For further practice of simultaneous equation method and repeated distribution method, let's understand another question. Let's understand illustration 2. A company has 3 production departments and 2 service departments. Distribution summary of overhead is: for production department A, amount is rupees 3,000, for B rupees 2,000, for C rupees 1,000, making total of rupees 6,000, and for service department amount is rupees 234, and for service department Y amount is rupees 300, making total of 534, and grand total is rupees 6,534. The expense of service departments are charged on a percentage basis, which is given as: for production department A it is 20%, for production department B it is 40%, for production department C it is 30%, and for service department Y it is 10%, and distribution of overheads of service department Y given as: for department A it is 40%, for B it is 20%, for C it is 20%, and service department X it is 20%. Distribute service department cost to production department using number 1 simultaneous equation method and number 2 repeated distribution method. Let's solve this question. First, using simultaneous equation method. As explained and given equation, we will use x is equal to a plus b into y and y is equal to a plus b into x. Here capital X stands for department X, small x stands for total overhead of X service department after apportionment of overheads of service department Y, capital Y stands for department Y, and small y stands for total overheads of Y service department after apportionment of overheads of service department X, and A stands for primary distribution of overheads of respective service department. Let's solve the example. Step 1, formation of simultaneous equation. Let's assume X denotes total overhead of service department X, Y denotes total overhead of service department Y. Therefore, X is equal to 234 plus 20% of Y, which will give us equation 1, and Y is equal to 300 plus 10% of X, resulting in equation 2. So, X is equal to 234 plus 0.20 Y, equation 1, and Y is equal to 300 plus 0.10 x, equation 2. Now, step 2 for solving simultaneous equation. Putting the value of Y in equation 1, X is equal to 234 plus 0.20 into 300 plus 0.10 x, which will give us X is equal to 234 plus 60 plus 0.02 x. Therefore, X minus 0.02x is equal to 294. Therefore, x is equal to 294 divided by 0.98. Therefore, x is equal to 300. X is equal to total overheads of X service department after apportionment of overheads of service department Y, and that is rupees 300. Step 3. Now, we have the value of x and we will put this value in equation number 2. Y is equal to 300 plus 0.10x. Y is equal to 300 plus 0.10 into 300, that is the new value of x that we have calculated. Y is equal to 300 plus 30. Therefore, y is equal to rupees 330. Y stands for total overheads of Y service department after apportionment of overheads of service department X, and that is rupees 300. Now, let us solve the example using repeated distribution method. We will prepare 4 columns. First, distribution of overheads of service department. Second is for production department, where we will prepare 3 sub-columns for department A, department B and department C. Third column is for service department X and Y, and last is total column. Total as per primary distribution given in the example is for production department A, it is rupees 3000, for B rupees 2000, for C rupees 1000, for service department X it is given rupees 234, and for service department Y it is given rupees 300, making total of rupees 6534. Now, let us distribute overhead of X department in the percentage given. Amount comes to for production department A rupees 47, for B rupees 94, for C rupees 70, and for service department 2 it comes to rupees 23. Now, let us distribute the overhead of Y department in the percentage given. It comes to for production department A as rupees 129, for B rupees 65, for C as rupees 65. Therefore, service department allocation comes to rupees 64. Now, let us distribute the overhead of X department. Distribution comes to for production department A rupees 14, for B rupees 25, for C rupees 19, and for service department Y rupees 6. Now, let us distribute the overhead of Y department. The allocation comes to production department A rupees 2, production department B again rupees 2, and production department C it is also rupees 2. Therefore, the total of production department A comes to rupees 3192, for B amount is rupees 2186, and for C amount is rupees 1156, and making total of rupees 6534. Now, rupees 300 total overheads of service department X will be apportioned amongst A, B and C in the proportion of 20%, 40% and 30%, that is 90%, because 10% are for Y department. In the same manner, rupees 3300 total overheads of service department Y will be apportioned amongst A, B and C in the proportion of 40%, 40% and 20%, giving 80%, because 20% are for X department. Let us understand secondary overhead distribution summary. Here 3 columns are given. First is for item, second is for total, third column is for production departments A, B and C. Total as per primary distribution given in the example is rupees 6000. For production department A, amount is rupees 3000, for B rupees 2000, and for C it is rupees 1000. Service department X allocation is 90% of rupees 300, amount comes to rupees 270. So, the distribution for production department A is rupees 60, for B rupees 120, for C it is 90. For service department Y, it is 80% of 330, amount comes to rupees 264, and allocation for production department A is rupees 132, for B again it is 132, and for C it is rupees 66. making total for production department A as rupees 3,192, for B it is 2,252, and for production department C amount comes to rupees 1,156. Total overheads of all departments are rupees 6,534, and after apportionment of overheads of service department of X and Y to production department A, B and C, it would remain same, that is rupees 6,534. In brief, you should note that and you should keep remember that in case of reciprocal method, all given service department are taking services manually, mutually. For example, canteen department is not production department and maintenance department are also not production department. Both are service departments. Canteen department may take services of maintenance department. Likewise, maintenance department may take services of canteen department. They are mutually dependent on each other. Finally, cost determination of production departments are done. Any cost of service department are to be transferred to production department irrespective of method of apportionment, that is either non-reciprocal or reciprocal. In this module, we dealt with reciprocal method for distribution of overheads of service department to production department. This method is used when service departments are dependent on each other. It means that service departments providing services to each other. For this calculation, two sub-methods of reciprocal method are used. Number 1, simultaneous equation method, and number 2, repeated distribution method. Under simultaneous equation method, accurate distribution can be done, but it is difficult to use when there are more than two service departments. On other hand, repeated distribution method provides approximate distribution but useful when service departments are more than two. In the next module, we will study about absorption of factory overheads. There are three stages of distribution of overhead. Number 1, allocation and apportionment. Number 2, reapportionment. Number 3, absorption. So far, we have studied about number 1, allocation and apportionment, and number 2, reapportionment. Now, in the next part, we will discuss about stage number 3, that is absorption. There are two steps in the absorption of overhead. Number 1, computation of overhead absorption rate, and number 2, application of these rates to cost units. Methods of absorption are number 1, percentage on direct material, number 2, percentage on direct wages, number 3, percentage on prime cost, number 4, direct labor hour rate, number 5, machine hour rate, and number 6, rate per unit of production. I hope you understand this session. Thank you.